Good morning, students. Today I want to speak about hydrocarbons. In previous lecture, we have completed some topics of the chapter number 15. In that, we have finished introduction to hydrocarbon about the alkane, isomerism in alkane, conformation in alkane, then industrial preparation, physical properties of alkanes. These points we will to discuss and some we discussed already. In that, we discuss definitions of hydrocarbons, classification of hydrocarbons. Later on, we discuss about the alkane, and later on, isomerism about that. Some examples I give, and I give some topics about the homework also. Later on, today, I am going to start conformation of alkanes. In conformation alkanes they have only the single bonded atoms because I told that carbon carbon single bondeds are there, and that's why they has the formula general formula of alkane is CnH10 plus 2. The single covalent bond is formed by coaxial overlap of the orbital and is called as sigma bond. And about that we're going to see, you can refer chapter number 5 in that hybridization theory and how these overlaps are there, and what is the coaxial means along the internuclear axis of the two atoms. In that, what are the two neighboring orbital of the same axis, they're going to overlap, means they're going to mix together, and by that mixing and recasting we're going to learn about the hybridization theory. And by such type of hybridization, what the bond we'll see that bonds are sigma bond. Almost remember, sigma bonds are stronger bonds, and they shows maximum extent of the overlapping. That's why these are stronger bonds. Remember these points. On the contrary, another bond you heard that pi bond, which are weak bond, and these are formed by lateral overlap or sidewise overlap. That we can discuss in chapter number 5 also. Later on, as a direct consequence of the coaxial overlap of the orbitals, sigma bond is what cylindrically symmetrical, and the extent of orbital overlap is unaffected by rotation about the single bond, and therefore carbon carbon single bonds they undergoes rotation. So what is this rotation concept? Remember, when our orbital is going to hybridize together, that orbital might be s orbital or p orbital. So these orbital they are going to overlap together. That time they are going to rotate also, and due to rotation they form such type of single bond, and this rotation also favorable to the space, and that's why they're going to show the particular bond angle as well as particular geometry to that new hybrid orbital of the new molecule. Later on, the atom which can be bonded to one carbon of this carbon carbon single bond, they changes their relative position with reference to the atoms on the other carbon of that bond on rotation of that carbon carbon single bond. What is meaning of the sentence? Whenever we'll see carbon carbon single bond, so in that, what the molecule we want to form, they shows their particular relative position with reference to the previous atom on the other carbon of the bond on rotation of that carbon carbon single bond. So it can be causes what new molecule which can be hybrid or hybrid molecule we'll see. Later on, resulting arrangement of the atoms in space about the carbon carbon single bond are called conformation. Now here arrangement, what kind of arrangements are there? Now what the overlap if we'll see, normally for your level we can discuss about the SS overlap, SP overlap, PP overlap. By such type of overlap we'll see the different arrangement, and these arrangements are favorable to the formation of the molecule toward the space, and that's why these arrangements are called as what? Conformation. Later on, innumerable conformations result on complete rotation of the carbon carbon single bond through 360-degree. Now as per this rotation of the particular geometry or particular bond angle, they can be decides the shape of the molecule, geometry of the molecule, as well as so many things we can study about this bond angle and these are form or the basic reason is that bond angle rotation or rotation about the axis. Later on in chapter number 14 there is the concept of the isomerism. Before this I told that isomerism means what? It is the phenomenon in which from same molecular formula we can get different structure, and this phenomenon is called as isomerism. And what the new molecule will see by the different arrangement of the structures, these molecules are called as isomers. Suppose example, in previous lecture also I told that suppose 4 carbon alkane means C4H10 butane. So butane can form how many isomers? It can be formed first of all straight chain means normal, that is of N butane, first isomer. Second isomer, here carbon carbon carbon, second carbon can be branched by fourth one. That's why this branching indicates what? The branch carbon alkane, and it can be called by the name of iso. So isobutane is the second isomer. So in this way, like this, pentane C5H12 also giving three types of isomer. Which one? N-pentane, isopentane, and neopentane. In structural formula, in previous lecture that I detail in detail I said already. Later on, this phenomenon of the isomerism, by this we can study the phenomenon of stereoisomerism. So what is this? Stereoisomerism is the phenomenon of existence of the conformation is a type of stereoisomerism. Stereo means rotation. By rotation of some molecule, atom, or these they can be rotate about the particular bond that can be causes the stereoisomerism. Later on, in conformational isomerism, the conformations means conformational isomers they interconvert by rotation about the carbon carbon single bond. Of course, about the alkane, about the singly bonded, that rotation about carbon carbon single bond. Suppose on the first carbon atom two methyl groups are there, so this methyl can be rotated to the first carbon atom in particular direction, as well as on second carbon suppose ethyl and methyl groups are there, so they can be rotated accordingly. Later on, out of the infinite conformations of the ethane molecule, two are extreme and called as staggered and eclipse conformation. So staggered and eclipse conformation. So these words you have to remember how these are and why these are, that we will to discuss with the help of some structure. Later on, these staggered or eclipse they can be represent the Sawhorse formula and Newman projection formula. So that we can discuss by the figure. So conformation isomerism in other alkane that also shows more complex. So in this picture you can see first of all staggered type of conformation, and later on we'll discuss about the eclipse. See, look at that staggered conformation. In case of staggered conformation, this is the first carbon. Around this first carbon, here 1, 2, 3, these three hydrogen atoms are attached. Around the second carbon, so here also 1, 2, 3, these three carbon atoms are attached. And you observe that the plane of symmetry, here this hydrogen towards each other, and that's why they can show the staggered conformation. In same way, if you are going to rotate, suppose this one, if you are going to rotate this position, by rotation we can get this position over here, and that's why what the picture or what the formula we'll see, that is of eclipse formula of the ethane, and this staggered and eclipse, so these both formula are invented by Sohor. That's why these are what Sohor's formula. Later on, second type is Newman projection formula. In case of Newman projection formula, we'll say staggered and eclipse. Suppose your one friend in front of you and you are behind of that one. So what are the observer? They can see only the first friend, which is what front side. Backside friend, they cannot see directly, but at least they can judge that backside somebody is there. Like that. What the first carbon? This first carbon is suppose this one, this first carbon. Later on, what the next carbon behind carbon? That we can shown by this circle. Remember this one. And that's why same picture we can observe in this way also. Front carbon that we can see over that this first hydrogen, second hydrogen, third hydrogen we will see. And over the back carbon, in the back carbon, in that hydrogen atoms are attached like this first hydrogen, second hydrogen, and third hydrogen in this way. So these are the same but different about the geometry, different about the what is the structural or pictorial representation. So this type of position in which centrally carbon has what this one two three hydrogen. What is the backside carbon? It has the hydrogen one two three like this. That's why this conformation is called as what staggered conformation. And if you rotate this one, suppose this hydrogen, if you're going to rotate, that time we can get such type of picture. It is called as what eclipse. So these both structures are invented by Newman projection. That's why it is for these formulas are called as what Newman projection formula. Later on, representation of the staggered and eclipse conformation of the alkane. In that representation, we'll say the industrial source. In industrial source, what the raw material is of petroleum. In that, the raw petrol, or you may say crude petrol, and the natural gas are the sources of the alkane. These are the main sources from mine or from, you know, that ONGC and that these companies, they're going to or Bombay High. From that, what the initial fraction of the gas coming out? So that is of methane. As per the molecular weight, we can say that these gases are coming out. Those who are less molecular weight, they comes first, and higher molecular weight, they comes later, like this. So here, crude petroleum and natural gas are the sources of alkanes. These are main sources of alkane. What are the dead plants? You may say fossil and that they buried under earth billions of the year ago and got converted into crude oil under the high temperature as well as high pressure condition. You know, what the buried animal or buried plants, so they start decomposition on their death, and that's why what are the due to decomposition of the nitrogen oxygen cycle, carbon cycle. So by that, these plants and animal, they start to decompose, and after so many years they going to convert, means what are the traces of their body or traces of their fractions of the body, they can be converted into the crude oil, and from that we can get such type of fraction. Next point that we'll discuss, the crude oil collected in dome shaped cavities under the earth surface, which we call oil wells. So it's very important concept. From the oil well, what are the dome shaped cavities are there on the earth surface, they can collect such type of oil. That's why these are called as oil well. Alkanes are obtained by fractional distillation of crude oil in oil refineries. So these are the uh, old concept, you may say, and by that we can get the fractional distillation. By fractional distillation, what the oil will get, that is what crude oil, and it is what in the refinery. Later on, next method we can discuss about the preparation of alkanes. That is what in that first point they said from unsaturated hydrocarbon. Unsaturated means what? Remember these two words. Saturated means carbon carbon single bonded. Unsaturated means carbon carbon double bonded. So here double and triple bonded are there. These are called as unsaturation. Later on, from unsaturated hydrocarbon, in that catalytic hydrogenation of alkenes or alkyne. Alkene means, you know, double bonded, carbon carbon double bonded, and alkyne means carbon carbon triple bonded. With dihydrogen gas, they give corresponding alkane. But finally, they are finely divided powder of the platinum or palladium catalyzes the hydrogenation of the alkenes and alkynes at room temperature. Later on, relative high temperature and resume and pressure, relative high temperature and pressure, these are required with finely divided nickel. Finely divided means what? Finely powder. Actually, we can use nickel in the form of what the you may say metal foil, or you may say metal strip. But the powdered nickel or finely divided nickel, is the base effective catalyst due to smaller size of the nickel fragments. Later on, these are plays the role of reducing agent. Remember. Now here, some reaction I am giving. These reactions are CH2 double bond CH2 means ethene or ethylene. It undergoes hydrogenation. What is hydrogenation? Addition of hydrogen is called as hydrogenation. So how we can perform this hydrogenation? That we can perform in case of or by using platinum catalyst or palladium catalyst or nickel catalyst. Now here this catalyst they can perform the role of this reaction under high pressure and high temperature. And here addition of hydrogen. In hydrogen molecule, two hydrogens are there. Out of that, one hydrogen goes to first carbon and second hydrogen goes to second carbon. That's why we'll get the product is CS3 single bond CS3. So this product is called as ethane. Similarly, what is the CS3 CH double bond CH2? So this is the propene. When propene reacts with hydrogen, means undergoes hydrogenation in presence of either nickel, platinum, palladium catalyst, and from that we can get the carbon-carbon singly bonded product, and that product is of CS3 single bond CH2 single bond CS3. So this product is called as what? Propane. Later on, from alkynes means triply bonded SC triple bond CH, it is of acetylene or alkyne, reacts with two molecules of hydrogen, and that addition will see in presence of either platinum, palladium or nickel catalyst under high temperature and pressure, it gives what? Ethane. CH3 single bond CH3, it is of ethane. Similarly, such type of reaction in that from double bonded reactant we can get the single bonded product, as well as from the triple bonded reactant we can get the single bonded product. Similarly, that reaction we can convert in the form of general criteria of the reaction. So here in the first step, alkene. Alkene when reacts with hydrogen gas at this catalyst nickel platinum. So from that we'll get CnH2n plus 2. Of course, from double bonded we can get the single bonded. Means what? Conversion of alkene to the alkane. Similarly, conversion of alkyne. Alkyne means CnH2n plus 2. CnH2n minus 2, which can be reacts with hydrogen gas. It gives CnH2n plus 2. So in this way, we can get the alkane. So in this step, conversion of alkene to alkane. So here conversion of alkyne to alkane. So in this way, we can prepare alkane. Later on, second method I want to discuss from alkyl halide. In that, first method is by reduction of alkyl halide. I said reduction means addition of hydrogen. Now here alkyl halides on reduction with zinc and dilute hydrochloric acid from alkane, the reduction of alkyl halide is due to nascent hydrogen, means single hydrogen. These are called as nascent hydrogen from the reducing agent zinc and dilute HCl. Example I gave CH3I means methyl iodide combines with two hydrogen nascent hydrogen in presence of zinc and HCl catalyst. Later on from this we will get CH4 means methane plus HI. Similarly, CH3 single bond CH2Br, so it is of ethyl bromide when combines with nascent hydrogen in place of uh, zinc and HCl catalyst. From this we will get two molecules of CH3 means ethane along with HBr. Later on in this second B method I want to discuss about by using reactive metals. In that, the 19th century of the alkyl halide were transformed to alkane having double and the number of the carbon by Wurtz coupling reaction. It's very important reaction. Using the reaction or reactive metal sodium. In spite of sodium, you can use zinc metal also. But the funda is that for zinc metal, if you want to use only one zinc. But if you want to use sodium, you have to use what? Two sodium metal. Remember this point. Somewhere you can see, you can learn that zinc reaction also. Otherwise, I will give separately in your assignment. Now here, this word reaction, basic purpose of the word reaction is that from lower alkyl halide we can get the higher alkane. Remember, once again I will repeat. The word reaction has theme or its aim is that by this reaction, by Ward's reaction, we can convert lower alkyl halide into the higher alkane, and that's why this reaction is very popular. Example I give, CS3Br means methyl bromide combines with 2 sodium and another side also CS3Br means methyl bromide, means totally these two molecules of methyl bromide when combines with 2 sodium atom, you may say, in presence of dry ether. So from this we can get first of all twice NaBr means as a byproduct, and the main product is CS3 which can be joined with this CS3. So this CS3 single bond CS3 is called as ethane. So in this reaction what happened? Two molecules of alkyl halide like methyl bromide and methyl bromide reacts with two sodium metal in presence of dry ether. It gives ethane along with twice sodium bromide. And later on, the later better methods by using metals such as magnesium, lithium, remember zinc also were developed. Later on, Grignard reaction is one of the new method widely employed for preparation of alkane, of course from lower alkyl halide. Later on, alkyl magnesium halides, that is of Gr means Grignard reagent. Gr is the short form I said. So it is what called as Grignard reagent. In this, they can be obtained by treating with alkyl halide. Preparation of GR that we will see in next lecture. So till today, we have to stop on the words reaction. Uh, Thank you. Stay home, stay safe, and take care. God bless you. Thank you.